Hi guys, Mr. Wallace here with another video lesson for you. This week we're going to be looking at a completely new topic, and I'm not appearing in the corner because I'm trying to get my screen that I usually use fixed for that. Try and improve it a wee bit, but we'll get right cracking on with what we're doing this week, okay? So, as usual, 3 questions on the board. Make sure that you're looking at them as you go through the video and thinking, can I answer these by the time you get to the end? And if not, asking for that help. Okay, I'll give you a wee moment to read them and then we'll move on. Okay, so when I talk about probability, what I'm usually thinking is asking you questions like, what are the chances if I look at this dice here that I'll roll a 5, okay? Or in a coin toss, what are the chances it'll come up heads? Okay. Last option, say there, just as an example, what are the chances I'd win the lottery? Okay, these are things that we commonly think of when we talk about probability. It's a really useful topic. I've put some areas or career kind of paths that quite commonly use a lot of probability at the bottom. Okay, when you get to the end of the video, feel free to go off and have a wee look at them a bit more. They're not the only options, but they're 3 that I thought of off the top of my head. Okay, so essentially what we're saying is probability is looking at something and thinking how likely it is to occur. Okay, so probability is how likely is it. I don't like when this does that. That in a particular event will happen. Okay, that's what we're talking about when we're talking about probability. How likely is it that a particular event is going to happen? The way that we work this out is we look at all the possible ways that that event could happen and divide it by all the different ways anything could happen in that scenario. Okay, so we'll start off by using as an example a coin toss. Okay, and what we're saying is our probability, which we quite often write in shorthand as P, is the number of favourable options, so number of options that we like, divided by the total number of options available to us. Okay, so number of options we like, the number of favourable options divided by the total number of options, how many different possibilities were there actually. So if we think about our coin toss, on a coin we have 2 possibilities. We can either have heads or we can have tails. So what I'm going to ask you is, what is the possibility if I were to flip a coin, I would end up with heads? Okay, so the way we write this is we say, what's the probability? We're using our P for shorthand, and then in brackets we write down what favourable outcome is it we're looking for. So what's the probability that we'll roll heads, or flip heads I should say. Okay, now we look over here, how many possibilities are there? How many possibilities are there we want? Okay, how many possibilities are there we'll end up with the result we're looking for, that heads? Okay, that's 1. There's only 1 option. It has to come up heads on the coin. We divide that by how many options were there in total. Okay, so we could have flipped the coin and got heads, we could have flipped the coin and got tails, so there are 2 total possible options. And what that tells us is the possibility of flipping a coin and landing heads is a half. Okay, and that's really all there is to describing a probability. It can be written as a fraction like we did here, but it can also be written as a decimal. Okay, That might come up a little bit further down the line, but for now we're just going to focus on when it's written as a fraction. And that means one of the number one things you should be thinking when you see other examples later in this video is, could my fraction simplify? Okay, I want you to keep your mind on that because that's important. We always simplify our fractions, even in a topic like probability here. Okay, we'll look at a couple more examples before wrapping up the video. First one we're going to look at is the next most obvious thing we had coming off the start, was a dice roll. Okay, so up the top we have all the possible outcomes we could have on a six-sided dice. We have a 1, a 2, a 3, a 4, a 5 and a 6. Okay, and there's 3 questions here. I'll go through them one at a time. First question is asking us, what is the probability that we will roll a 4 on this six-sided dice? Okay, the probability P, we will roll a 4, so we put 4 in brackets. Okay, you could write P4, or in this case I'd probably let you away with writing P bracket 4. Okay, but that's going to equal, how many chances are there that we could roll a 4 on this six-sided dice? Well, there's only one side on the dice that's going to give us 4 as an answer. Okay, so that means there's only one favourable outcome, only one way for us to roll a 4. But there are 6 possible sides that could land up when we roll this dice. Okay, so that means there's 6 total possibilities, including the 4. Okay, so that means our probability of rolling a 4, all we have to do is write it down as a 6th. Okay, and again, we're not going to worry about the decimals too much at this stage. Pretty straightforward there so far. Okay, next one adds a wee bit of extra difficulty. We're looking at, what is the probability that we will roll an even number on this dice? Okay, so this time we're not just looking at 4, we're looking at all the even numbers. So we have 2, we have 4, and we have 6. Okay, the way that I would go about writing this down is I would say the probability I'm going to roll an even number equals, okay, and again it's that outcomes we want divided by total number of outcomes. Okay, so there are 3 possible ways that we could roll and get an even number. We could either roll and land on a 2, a 4 or a 6, and there are still 6 total possible outcomes because we could roll any one of the numbers in reality. That means our probability of rolling an even number is 3 over 6, but you should be thinking, does this now simplify? Okay, it was pretty obvious this one wouldn't. Have a look at this one and think, is there a common factor? Okay, if you think about that for long enough, you should hopefully spot we have a common factor, top and bottom, of 3. Okay, that's our highest common factor. So we're going to divide the top and bottom by 3, which tells us that the probability we're going to roll an even number is actually a half. Okay. Last one in this example is, what is the probability that we'll roll a number smaller than 3? Okay, so P less than 3. So to think about this, there are only 2 numbers on the dice less than 3. Okay, you should hopefully realise that it's the 1 and the 2 here. Okay, so that means there are 2 numbers we could land on that are less than 3, but we still have 6 sides we could land on the dice, so our probability is 2 over 6. Again, thinking, does this simplify? If you look at it, you should see that they this time have a common factor of 2. They both divide by 2. Okay, so we're going to divide top and bottom by 2 to get our final probability of 1/3. That's all there is to these questions so far, guys. Okay, so that's looking good. We'll look at one more slightly tougher example, just increasing the difficulty of simplifying the fractions, and then we'll wrap this video up. This one here is a bit of a word problem. It says a bag contains 24 marbles. Okay, so what we're interested in here is the bag has 24 marbles in it. Okay, keep that in mind. 18 of them are blue and 6 of them are red. The question is 2 parts. We'll look at part 1 first. So part A, what is the probability that a blue marble will be pulled from the bag? Well, we're going to write this down as probability of blue, okay? probability that our marble will be blue. There are 24 marbles in total in the bag. 18 of them are blue. That means if we reach in and grab one marble, 18 of those chances will result in a blue marble out of the 24 total marbles that were in the bag. So it's really just lifting the appropriate numbers from the question. Okay. You wouldn't get all the points for that because you've not simplified. You need to try and find what the highest common factor is between 18 and 24. Give it a bit of thought. You should hopefully realise that it is 6. Okay, so we're going to divide top and bottom by 6. And we get a probability of blue that is going to be 3 over 4. Okay, so our probability of pulling a blue marble from the bag is 3 over 4. We're going to do the exact same thing just to wrap up, but this time it's asking us what's the probability we'll pull a red marble from the bag. Okay, so P red, our probability that we'll pull a red marble out, is going to equal. Now there are only 6 in the bag, so there's only 6 times you could reach in and lift one marble and end up with a red one. We divide that again by how many marbles there were in total in the bag. What's our total number of possibilities? 24. We have to simplify it again. Looking at it much like the last one, you'll still just have a common factor of 6. Okay, so you divide top and bottom by 6 for a final probability of 1 over 4. And that is all there is to the questions we'll be looking at this week, okay? Maybe later on in the week we'll add a wee bit extra difficulty in, but for now that's what we're focused on, okay? So, I hope you found this helpful, guys. Remember to go through these questions and make sure that you can answer them based on what you've learned from the different parts of this video. And if not, make sure you're asking the teacher assigning you your work for a bit of help. Okay. Otherwise, I hope you have a great week. We've got National Numeracy Day coming up in the middle of the week. I'm sure there'll be some great stuff going on for that. Keep an eye on it and have a good one. See you later, guys.